Hello, everyone, and welcome to this week's edition of Data Raven's YouTube channel for data science. Today, we're going to talk about Python libraries for data science. Now, this is another introductory video, and when you think about the business problem that we're trying to solve here, what we're really talking about is, you're getting ready to do some data analysis work in Python, and I really want everybody to understand the main libraries that are out there to help you do that. So when we think about those libraries, these are really the big libraries that we're talking about here. And there's really three groups. There's the scientific computing libraries, there's the visualization libraries, and the algorithmic libraries. And we're going to start today with the scientific computing libraries, and we'll do another video about the visualization and the algorithms. But basically, we've already reviewed the pandas, so I'm not going to spend a lot of time today looking at the pandas. Today, we're going to mostly talk about Numpy and Scipy. So Numpy, and that's the way you say it. I think when I originally started, I called it Numpy, but it's Numpy is the way they pronounce it. And basically, Numpy, it's open source, just like the rest of Python, and it's used in almost every field of science and engineering. It's a universal standard for working with numerical data in Python, and it's the core of scientific Python and PyData ecosystems. And the second one is Scipy. So Scipy is, again, and the links for both of these are both in the PowerPoint here, as well as they'll be in the code page on the GitHub for the YouTube channel. But Scipy has a lot more functionality on it. It's actually based on Numpy, and it's a collection of math algorithms and tools that it builds convenience into use in Python. And you'll see how they build on one another in the example. It adds significant power, makes Python interactive, and it provides the user with a high level of commands to manipulate data and visualize data. So let's go ahead and jump right in. So here I have a notebook it built in Python and a Jupyter notebook. And one of the things we'll talk about is best practices. And what you'll see here is I've also put the web addresses in there and also the title for this particular section. So anytime in Python and in R that you're making a comment, you use the number sign or the hashtag to delineate that this is a comment. And even if I was actually to run that section of code, nothing's going to happen because it's all comments. So the next thing we're going to do here is we're going to import Numpy. And you can see here, I think I mentioned this before in a previous video, but when you import it, you can import it as an abbreviation. So what you're saying here is import the Numpy library as NP. That's just shorthand. It's the standard shorthand. NP is the standard shorthand, so that you don't have to type out Numpy every time. So we'll go ahead and run that. And you'll see here that normally, it could take a little while to run, 2 or 3 seconds to run these cells to actually load it in. So one of the things that Numpy does mostly is arrays. And this is from a machine learning project that I did here to actually predict the winner of this past year's NBA playoffs. And what I did here was just to show, and anytime you're going to use a command and going forward, now you can see here, since we imported Numpy as NP, we're saying here, let's create an array called known years, and we're going to use this command called arrange. So NP arrange 1990 through 2021, and as a type of an integer 64. So all this is going to do is, and then all I'm doing here is when I type out known years, I'm just typing out and saying, show me what it looks like. So when I run that, it's going to show me my array, and it basically tells me the array and how it's set up. And then it also says here that, again, I said I want it to be an integer 64. Another thing that Numpy does is math features and functions. So for example, you could actually type in here as a calculator, 1 + 4 + 3, so on, and divide it by the total number of numbers and get the average. But here we'll just use the command mean. So again, NP mean, and when I run that, it's going to give me a mean of 3.5. Same thing with the variance. We'll run this, and it tells me my variance is 6.4. We're going to import this program called PyJet. And at some point in the future, we will show here how these functions work and how to build a function. But basically what I'm doing here is I'm importing a bunch of tools. And what we're going to do here is we're going to show how Numpy is used to basically to build a function and to show how this algorithm will find its way or find the shortest path through a maze. So this is a large function. I'm not going to go in the details of every piece of it, but I'm just going to walk you through real quick and show you where Numpy is adding value into this particular subject. So you can see here again, we're importing it. We're making sure that it's going to work. We're saying we're going to define a function called build a maze. And here we're going to say, it has a shape, it has a complexity. And then here we're using the command called numpy zeros or np zeros to actually build the actual maze. Again, down here, we're using the command np random, which is probably the command in NumPy that I use the most to create random numbers. So we're creating that here. Again, as we go through, we're going to create the islands or the walls in the middle of the maze. And then we're going to use a methodology here. Again, we're going to call this np0. We're going to again use np again down here to say empty like. And then we'll use it a couple more times in here as well for again, here's another one where I'm creating an array about the path. As we go down further, we can see here now we're going to go ahead and we're going to plot this particular thing. And then we're going to see an actual plot. So again, the purpose here is to show you how NumPy is used in this mathematical problem and solution here. And we'll go ahead and run this. And what it will do is we'll then come in and we'll say, okay, we're going to create a, what'll happen here is you can see now that my hourglass. Okay, so we can see now here that my hourglass is turned into a book, and I actually have a number up here, again, saying that this was basically the 7th transaction that I ran in this particular work session. And you can see here that down below, it's gone ahead and it's created the maze. And really, this is just a graph. It's, the system sees it as a graph, not really as a maze. But basically, the algorithm or the methodology figured out the shortest path through the maze. And again, not trying to make you an expert on this particular algorithm or making a maze, just trying to show how NumPy works in this particular function. Here's another one here that we're going to use to, again, do some mathematical calculations. Again, this is a function here that we're creating, and then we're going to run some random data through it. So I'll go ahead and again, I'll run this. And you'll see this will run anytime you define a function, it goes pretty quick. And then what we'll do here is we're going to say, okay, we're going to run that function using this data. So again, NumPy is going to create a random set of 1,000 numbers. It's going to run this function and it's going to give me a plot. And when I do that, this is what I get. I get the plot. So again, just showing the functionality of NumPy and how it works and how it supports various mathematical functions. The next one we're going to talk about is some examples of Scipy. And we're going to jump in here into the first one is if you remember back from your college or high school days when you had calculus and integrals. So here's an integral, a pretty simple integral where we're integrating between 0 and 4.5 j to the 2.5 of x dx. And here's where again we can bring Scipy. We'll import it in. These are pieces. Integrate and special are part of Scipy. And when we bring this in, we'll bring that in, and again you'll see it may take 5 or 10 seconds depending on what it's going to bring in, but then it does the solution for us. And this is how you represent that integral in Python. So it tells us that the result there is that's my integration result. Another one you can remember definitely from your high school days was trying to solve simultaneous equations. And the way Scipy does this is through linear algebra. So basically what it does is it creates, you create an array using these values of x, y, and z to basically solve for x, y, and z. And when you do that here, again, you can bring this in, you import this module or this part of the Scipy library called linear algebra, or LinALG for short. You put in the 1, the 3, and the 5. You put in the 2, the 5, and the 1. And then you put in the 2, 3, and the 8. And then you put in the answers here of 10, 8, and 3. And then when you run this, it solves, it gives me a solution as an array. So what this is saying is x is minus 9.28, y is 5.16, and z is 0.76. And you can see how quickly, don't show your high school students how to do this for solving simultaneous equations. I remember doing it longhand, but this is just some proofs here just to show x, y, and z in the different formulas up here. So this also shows how you can use Python as a calculator. So when you do that, there's my 10, this is my 8, and there's my 3. So what I'm going to do is, because of the graphics here, I'm going to go ahead and restart the kernel, and really that just means resetting it to basically clear the memory. And what you'll see will happen is all those numbers drop out of there. So we're going to come down here, and I'm going to go ahead and import a module from Scipy called stats. And then what I'm going to do here is I'm going to show that, again, using one of the things you'll see used quite often in data science is when you're trying to replicate the results and you create a random seed. You don't always use a crazy number like this, but this is just saying use a random seed, and you could call it 100, you could call it 1, whatever it is. And then that way, when somebody tries to replicate your results, it will pull those same random numbers. So we'll run this, and it's going to create a value for x. And when we do that, oh, hold on, I gotta add in Numpy again. So run this again. So there we go. So anytime you get an error like that, if you get that error, it says NP is not defined, you forgot to load the program back in. And remember, I restarted the cache. So when I did that, now what I'm going to do is when I run this, I'm going to say, okay, again, I created a number of numbers, 1,000 random numbers here. And basically, when I print the minimum, the maximum, the mean, and the variance, you can see that formula is a little different than Numpy. It's equivalent to those same functions, but when I run that, it's just going to give me all those numbers. It's going to tell me, the minimum's minus 3.7, the maximum's 5.2, the mean is 0.014, and the variance is 1.28. So here's an example of where I'll go ahead and I'll create to do univariate estimation. Again, I'm bringing in we'll talk more about matplotlib library next time. But again, this is just another type of example of how these libraries can be used. So when I do that, what this is really showing is it's basically giving me an array here, -7, -5, 1, 4, and 5, which are actually plotted on this chart. And it's showing the based on the distribution. You can see, again, it's using Numpy to build the array. And, it's also doing some calculations based on different formulas or different methodologies. And then another one here that I'm going to do is I'm going to show, again, just how to create some different plots. I'm going to import this module called stats. I'm going to create a couple random numbers using a normal distribution. So I'll go ahead and run this. I'm going to do what's called a kernel density estimate. So I'll do some more calculations down here. This is primarily the one here that's part of the Scipy, is this Gaussian density estimate. So when I run that again, and then when I do my plot here, I get this is called a density plot to show the density in this particular formula. So again, just trying to show these different libraries. What you'll see is some formulas you use more often. Like I said, I use the NP random a lot. I don't always necessarily do a normal distribution. It just depends what I'm doing. Sometimes I do some array work as well, but I was just showing you, again, just a variety and how to use this. So again, hopefully this has been helpful to you. Again, the links are in the or will be in this workbook posted up to the GitHub site for the YouTube channel. And remember, if you like us, please like the video and subscribe. Thanks, and we'll talk to you again later this week.